Hello and welcome to this lecture on integral calculus. In this video, we are going to see about triple integral and finding the volume of sphere using it. So, first, they asked to find the volume of sphere using a triple integral. They have given the equation of sphere. So, a simple thing, we know that a sphere is symmetric about all coordinate planes. So we compute the volume in the first octant. So totally there are 8 octants. So totally there are 8 octants. If I find the volume in the first octant alone, then if I multiply with 8, then it will be very easier to compute the total volume of a sphere. Okay. So how do we solve this? By using a triple integral. While finding this, the general thing will be of triple integral. Either you can use dx, dy, dz, or else 8 into triple integral dz, dy, dx. There are two forms. Either you can choose dx, dy, dz, or else dz, dy, dx. Sorry. Okay. So of course it is more familiar. I may go with this dz, dy, and dx. dz, dy, dx. So if I choose x as that a variable, the corresponding limit will be on this inner integral. So how do you find the limits of these three variables? They have given the equation. Simply, this is our first octant. This point will be of 0 comma 0 comma 0. So every variable starts with the origin 0 comma 0 comma 0. Simply every limit will be of origin as 0. So the lower limit will be 0. So first thing, just take the given equation and just compute the z value. So z square equal to a square minus x square minus y square. So z can be written as a square minus x square minus y square. So this is the lower limit and this is the upper limit of z. Then if you go for y, simply I have told you that everything a lower limit will be 0. So you just take this and come evaluate equal to equate y to 0. Then you will get the value of y will be square root of a square minus x square. So this will be the upper limit, this will be the lower limit. If you go for x, so what is happening here? Simply z is a lower limit is 0 and the upper limit will be square root of a square minus x square minus y square. And if I go for the next limit as y, I will evaluate the given function with respect to z. There will not be any term in the form of z. Okay, next I am going to evaluate with respect to y. So that limit of y should not contain the variable y. So we are removing the variables as so. And if I go for the next thing, I may equate x to 0 and I will find the value x equal to square root of a square. So this will be the lower limit, this will be the upper limit. Okay. So with this, I'm computing the integral limits for all the three variables by fixing the values of x, y correspondingly. So this will be the triple integral evaluation to find this volume of a sphere. So first what we will do, we will compute the inner integral part. So simply integral dz will be of z alone. Here the limit is 0 to a square minus x square minus y square. So we will substitute the limits, upper limit minus lower limit. Now you will get the value as a square minus x square minus y square. This will be the value for this inner integral part. So I have evaluated the inner integral part. Then what we will do? Then I will substitute this back and I will go for the evaluation with respect to y. So now I am going for the second integral with respect to y. So here, other than y, the remaining a and x are constants. So what I am doing is I am just making assumption a square minus x square as a, simply a constant, no? So I am making this as simply a minus y square. Already we know the formula for it. Uh, Integral a square minus x square can be written as the same, no? In the place of capital A, it is will be small a. In the place of y, here it is x. The same thing we have studied with that root of a square minus x square plus a by 2 sine inverse of, here it will be x by a. So the same thing, what we will do the next, I'm substituting the limits. In the place of y, I'm substituting the limit of square root of n, I will get the 0. So it is 0. And if I substitute square root of n, I will get the value of sine inverse of 1. This will be equal to 1. So sine inverse of 1 will be 90 degree pi by 2. Then if I substitute 0, this term becomes 0. Here it will be 0. And if I substitute the value of 0, sine inverse of 0 will be 0. So finally, I'm getting this a by 2 into pi by 2. So a pi by 4. Now I have to substitute the value back. So pi by 4 into a square minus x square. Okay, then I'm taking out the a pi by 4 a square minus x square to the last integral with respect to x. So I may keep that pi by 4, it will be of 2 pi after cancelling that a square minus x square into dx. Okay, so now I have to evaluate this part. You can split this integral. 2 pi will be a constant. I am splitting out the integral a square. Of course, a square is a constant. So we may keep a square outside and dx minus integral 0 to a x square dx. So this will be equal to 2 pi, then a square and x 0 to a minus x cube by 3 and 0 to a. So finally here it will be of a cube minus a cube by 3. If I am simplifying this 3, here it will be 3a square a cube minus 2a cube. So at last 4 pi a cube by 3. Okay. So finally we get the volume of sphere. That's all.